Hello and welcome. Let's solve this question on linear motion. The distance from city A to city B is 720 kilometers. A Nissan Matatu left A at 8 a.m. and traveled towards city B at an average speed of 90 kilometers per hour. Half an hour later, a car left city A towards city B with a 30-minute stop along the way before it caught up with the Nissan Matatu. If the car caught up with the Nissan Matatu at 12:00 hours, calculate 1. The distance covered by the Nissan Matatu when it was caught up by the car. 2. The speed traveled by the car. Then 3. The time the car arrived at city B. And then we have the other question here. Priska took a train from Mombasa to Nairobi. During the journey, another train was traveling in the opposite direction on the parallel track at 25 kilometers per hour. If the train she boarded was traveling at a speed of 15 kilometers per hour and it took 10.8 seconds to completely pass the other train, calculate the length in meters of the train Priska was traveling in if it was twice as long as the train moving in the opposite direction. So those are the questions. Let's go to the first part. So the first part, you're required to find the distance covered by the Nissan Matatu when it was caught up by the car. Now the car caught up with the Nissan at 12:00 hours. The Nissan Matatu left city A at 8 a.m. So we can get the time traveled by the Nissan Matatu before catching up. So that is from 8 a.m. So time by Matatu will be given by, we simply take 12:00 hours and we subtract the time it began the journey, that is 08, that is 8 a.m. which is 08:00 hours, and this will simply give 4 hours. So that was the time taken by the Nissan Matatu before catching up. Now, to get the distance, this is how we are going to, because we need to get the distance covered by the Nissan Matatu. So we're going to use this formula. Time is given by distance divided by the speed. So we already have the time. The time is 4 hours. Then the distance is what we don't have. So we can let the distance be represented by small d, the distance covered by the Nissan Matatu, divided by the speed of the Nissan Matatu was 90 kilometers per hour. And by use of this now, we can get d. So d is equals to 4 hours times 90 kilometers per hour. And this will simply give 360 kilometers. So that was the distance covered by the Nissan Matatu when it was caught up by the car. Part 2, the speed traveled by the car. Now the car began the journey 30 minutes after, that is half an hour later. So if the Nissan Matatu left city A at 8 a.m., therefore the car left half an hour later, that is at 8:30. So from 8:30 a.m. to the meeting point, that is at 12:00 hours. We need to get this time in order to help us to get the speed. So this time from 8:30 a.m. to 12:00 hours, when you subtract these, 12:00 hours, subtract 08:30 hours, this will give 3.5 hours or 3.5 hours. After getting that, now we get the speed. How do we get the speed? You're going to use this time. So time taken by this car is equals to distance from point A to the meeting point divided by the speed. So time taken, we already got that, that is 3.5 is equals to the distance from point A to the meeting point. We just calculated that from first part, that is part A. The distance is still the same, covered by the Nissan Matatu. that is 360 kilometers. 360 kilometers divided by the speed. So we'll be able to get the speed now here. So we get the speed, S is equals to, this will be 360 kilometers divided by 3.5 hours, or 3.5 hours. And this will give, we'll give it in form of fraction. This will give 102 and 6/7 kilometers per hour. So that is the speed traveled by the car. The next part, the time the car arrived at seat B. The time the car arrived at seat B. So the car started the journey at 8:30. Then there is a 30-minute stopover. It is here, 30-minute stopover is on. So we add that. 30-minute stopover, so plus 30 minutes. Then from there, to continue with the journey up to the finishing point, that is point B. Remember, the journey is not complete. So it started at 8:30, then 30 minutes, that is a stopover. Then it continued with the journey up to point B. And now, to get that speed from now the stopover to the end of the journey, that is at point B, we're going to get the time by taking the distance, and the distance that you're going to use in this case is the distance from A to B, that is 720. So distance, that is 720 kilometers divided by the speed of the car, which is 102 and 6/7 kilometers per hour. So this will give the time now from the stopover to point B. The distance from A to B, 720 kilometers, divided by the speed of the car, which is 102 and 6/7 kilometers per hour. So this will give, so we now can get now the time by simply taking 8:30, then we add 30 minutes, that will be 9 a.m. Then when you work out these, 720, just use the calculator, 720 divided by 102 and 6/7, this will give 7 hours. Just work out that using a calculator, just divided that. So this will give 7 hours. So we add 7 hours, and this will give 16:00 hours, or 4 p.m. Priska took a train from Mombasa to Nairobi. During the journey, another train was traveling in the opposite direction on a parallel track, 25 kilometers per hour. So there is a train that is moving from, and there are two. Another one is moving the opposite direction. So from Mombasa to Nairobi. So one train moving like that. During the journey, another train was traveling in the opposite direction, the track, and was moving at 25 kilometers per hour. If the train she boarded was traveling at the speed of 15, this is the train she boarded, 15 kilometers per hour, and it took 10.8 seconds to completely pass the other train. Calculate the length in meters the train Priska was using was traveling in if it was twice as long as the train. So this first train, look at the first train. The first train which Priska was using was twice as long as the train moving in the opposite direction. So we can let the train moving in the opposite direction to be x meters long, and then the one she was traveling was twice that. So this one will be twice that, 2x meters long. So the question, you're supposed to calculate the length in meters of the train. So this train, is what you're supposed to do that. Now, using the information that you already given here, you will be able to calculate the length of the first train. And since these are two bodies that are moving relative to one another in the opposite direction, the first thing we're going to do is to obtain the relative speed. So we get the relative speed, that is the first thing, because these two bodies are moving relative to one another in opposite direction. And because they're moving in the opposite direction, you shall add, so 15 plus 25, and this will give 40 kilometers per hour. Another thing, since the distance is given in meters, the length of this train is given in meters, and also we can see there is a time in seconds here. It is always advisable to convert 40 kilometers per hour to meters per second. How do we convert kilometers per hour to meters per second? The easiest way is always by taking the speed in kilometers per hour and multiplying it by 5. This is a constant value, 5/18. That is the easiest way, converting from kilometers per hour to meters per second. So this will give 100 divided by 9 meters per second. So we have converted that, and now we can be able to proceed from there. Now, time to completely overtake each other is going to be given by time to completely overtake each other, represented by t, will be given by the distance, and in this case, distance will be the total length of the two trains. They're the ones that are completely overtaking each other and using 10.8 seconds. So we shall take the distance divided by the relative speed. So from here, this is what you're going to do. Time, which is given by 10.8 seconds. So 10.8 seconds, time taken to completely overtake each other, is equals to distance, which will be the total length of the two trains. That will be the distance. And this will be 2x plus x, which will be 3x. Total distance. The first train is 2x meters long. The second one is x meters long. Total distance will be 3x. Then divided by the relative speed, which is 40. Not 40. You're not going to use 40. Remember, we converted that to meters per second because we're dealing with seconds here. So this will be 100 divided by 9. So from here, we'll be able to get x, and that will help us to get the length of the first train. So from here, let me work out this. So this one will be given by 3x multiplied by 9 over 100, and this will give 27 divided by 100 if you simplify that. And therefore, you shall have now from here 10.8 is equals to, I've simplified the whole of the right hand side to be 27. And this is 27x, 27x divided by 100. So therefore, making x the subject, x will be given by 10.8 times 100 divided by 27. And this will give x as 40. So therefore, we already have x, remember x meters, that is the length of the second train moving in the opposite direction. That means it will be 40 meters. The first one is twice that. And therefore, the one that Priska was traveling, it will be 2 times 40, and this will give 80 meters as the solution.